Hello everyone. In this video I am discussing about IP addressing. So IP is Internet Protocol and it has addressing scheme. Basically it has two versions, IP version 4 and IP version 6. And this IP version 4 has 32 bits and that is divided into 4 octets. So octets, that is 8 bits, that is each block contains 8 bits. Okay, and again this 8 bits are converted to decimal number and it is separated with dot. That's what is called as dotted decimal notation. Basically it's a binary number, so we have to convert it to decimal. So when you convert it to decimal, starting from all zeros to all ones, that is you will get around 4.3 billion IP addresses. That is IP version 4. And now we have IP version 6. It is of 128 bits. It is divided into 8 blocks and 8 quartets. Each quartet, each block contains 16 bits in binary form, and you have to convert into hexadecimal form. And when you convert 16 bits into hexadecimal, we will get 4-digit hexadecimal number. And it is separated with colon. That's what is also known as colon hex notation. Okay, so we'll discuss more about IP version 4. We'll have a separate session for IP version 6. So this IP version 4 is divided into 5 classes. Basically it has 5 classes. So that is class A, class B, class C, class D and class E. And first this class A range is between 0.0.0.0 to 127.255.255.255, and then class B range starts from 128.0.0.0 to 191.255.255.255, and then class C range 192.0.0.0 to 223.255.255.255, and then class D range is 224.0.0.0 to 239.255.255.255, and class E range, that is 240.0.0 to 255.255.255. So these are the 5 classes. Now first 3 classes A, B and C is a unicast address. It is used in LAN and WAN communication, used in local area network and wide area network. And then class D is for multicasting, used in multicasting. It's for multicast. And class E is for research and development. So like this we have 5 classes. Again in these 5 classes, so we are using these 3 classes for LAN and WAN communication, right? And in these 3 classes again we have something called private IP addresses. So what are those private IP address ranges for these 3 classes? So private IP address. Now what is this private IP address? This private IP address is used in LAN. There are certain IP addresses which are reserved for LAN or called as private IP addresses. And in class A, private IP address range is 10.0.0.0. It starts from 10.network and it ends at 10.255.255.255. One class A network is reserved for private IP address in class A. And then in class B, the private IP address range is 172.16.0.0 to 172.31.255.255. And then class C private IP address range is 192.168.0.0 to 192.168.255.255. These are private IP address ranges for these class A, B and C. And again in these 3 classes we have something called octet format. So in IP version 4 we have 4 octets, that is octet format. Now what is this octet format? Say this, in class A, first octet is reserved for network portion, and remaining 3 octets are reserved for host. Okay, and similarly in class B, first 2 octets are reserved for network, remaining 2 octets are reserved for host. And in class C, 3 octets are reserved for networks, and the last octet is reserved for host. Fine. So this is called as octet format. And next we will see subnet mask. Now what is this subnet mask? Subnet mask is used to differentiate between network portion and host portion. Okay, and it is also used to identify the network ID of a particular host. So we have class A, class B and class C, 3 classes. And class A, so how do we get subnet mask using octet format? What is the octet format for class A? Network, host, host, host. And for class B octet format, network, network, host, host. And class C octet format, network, network, host. Now if you want to find out subnet mask, you have to take network bits as ones and host bits as zeros. Always network bits are ones, host bits are zeros. Right? Now if you take network bits as ones, that is all ones, say this. How many ones? In each octet, 8 bits. So if you convert this 8 bits into decimal, so how to convert binary to decimal, how to do that operation? Say this. This is, we have to take base as 2, we have to write from powers starting from 0, from right to left in ascending order. 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, 2 power 7. Right? And this 2 power 0 is 1, 2 power 1 is 2, 2 power 2 is 4, 2 power 3 is 8, 2 power 4 16, 2 power 5 32, 2 power 6 64, 2 power 7 128. And if you add all these numbers, so if you want to convert binary to decimal, you have to multiply these numbers with ones and then you have to add. If you add all these numbers, you will get 255. So for all ones in decimal form, for all ones, binary ones, decimal is 255. Network portion all ones. So all ones means 255. And host bits are zeros. For all zeros, I can write as 0, 0, 0. Host portions are zeros. And similarly for class B, first network portion for all ones 255, and second octet all ones 255, third octet zeros, all zeros 0. And similarly in class C, we have 3 octets for network, that is network bits ones, all ones 255, all ones 255, and then all ones 255, last octet is 0. And these are a default subnet mask. For normal network, we can use this as a subnet mask. And if you do subnetting, subnet mask will change. Okay?